We are diving into a real FE exam Q, a cool math challenge that will test your brain power. It's a classic physics puzzle involving vectors. Vectors are super important in understanding how forces interact in engineering and physics. So, grab a notebook and let's get into it. Imagine three forces acting on a point in space, just floating there. Force 1 is pushing straight up. That is what you see here. This is the force F2. And tricky one, force 3 is pushing at a sharp angle, 120 degrees with the x-axis, 3 newtons. And your challenge is to find the overall force on the point, which is at the origin. We call this the resultant force. So once again, take a look at this diagram. These are the three forces given in the question, and we have to calculate the resultant vector of all these three forces. So before we jump into it, if you are new here, don't forget to follow my channel for free FE breakdowns on real FE questions that you will actually see in the examination. So make sure to follow so you never miss out on the fun. Let's break it down. We will use some cosine and sine to resolve these forces into x and y components. Then sum them up to find the magnitude of the resultant force. Remember your trigonometry, cosine of x, sine for y. So simply put, for the force F1, there is no x component, but the y component is 3 Newton. For the force F2, there is no y component, but the force of x component is 3 Newtons. For the force F3, which is the only complicated one, the x component of it is going to be F3 cos theta, where theta is the angle with its x-axis. So F3 cos 120. And its y component is going to be F3 sin 120. Got it? So once you find all the individual x and y components of all these three forces, add the x components separately and y components separately. Then the resultant force R is equal to root of fx square plus fy square, where fx is sum of all the x components and fy is sum of all the y components. So pause the video right here and try to solve this problem by yourself. So here you go guys. In step number 1, we resolve all the forces into components. F1x and F1y, 2x, F2y, F3x and F3y. Here it is 3 times cos 120. That is the x component of the third force, which is going to be negative because it's slant and it's in the negative x direction. And then there is F3y, which is going to be 3 sin 120, which is going to be positive because it is still going to be in the positive y direction. So sum of all the components is going to be Rx is equal to F1x plus F2x plus F3x, which is 0 plus 3 minus 1.5, which is equal to 1.5 newtons. Ry is equal to sum of all the y components, which is 3 plus 0, 3 plus 0 plus 2.6, which is going to be 5.6 newtons. So magnitude of the resultant vector is equal to root of Rx square plus Ry square, which is equal to root of 1.5 square plus 5.6 square, which gives us 33.61 root of 33.61, which is equal to 5.8 newtons. So which is very close to the approximate resultant force of 6 newtons. So if you take a look at the problem here, out of all the 4 options, option C is the closest one. So C is the correct answer.